Semantic Kernel and AI with Scott Hanselman.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software engineering firm serving companies struggling with past failures of business-critical software projects. They really deliver, establishing high quality, achieving rock-solid stability, and moving at the speed of your business. So when failure is not an option, ClearMeasure guarantees your project, and you can find them at clearmeasure.com. A quick announcement, my architect forums are going strong. Signups for the next session are up. And if you lead a software team and are looking to collaborate with other peer architect leaders, just sign up at the link in the show notes. And for those of you looking for Programming with Palermo, my video podcast, you can just search for it in any of the directories and you'll be able to find it. My guest today on the show is Scott Hanselman. He's a teacher at heart. He speaks all over the world to whoever will listen. He's written code that you, dear listener, have probably used, and he's been blogging and coding and podcasting a long time. He codes and writes and speaks and empowers and promotes and braids and learns and listens, usually not in that order. And he's also a vice president at Microsoft in his day job, and you can find him on YouTube, TikTok, Instagram, Mastodon, all kinds of places. His Hanselman podcast is on over 9,000 episodes. His Azure Friday show is well over 750 some odd episodes. You can connect with him at hanselman.com. Scott, welcome to the show, my friend. How are you, sir?
I'm very well. Thank you, sir. I will correct you. I have only 900 episodes, not 9,000 episodes of Hanselman. I will eventually get to 9,000.
Okay.
But I'm at 930 right now. Yeah, 18 years.
I had 900 in my notes, so my eyes are just failing me.
No, it's all good. It's all good. Yeah. It's a very long running every Thursday for the last, 18 something years.
Yeah. And our industry has just exploded. I think you can proudly claim to be one of the gray hair sages of the industry experience wise.
I don't know if that's a good thing or a bad thing, but I would probably give that to, Grady Booch or Martin Fowler, but I am still here and I'm still vertical and well blessed.
Yeah, very good. Well, I would say the first 10 years of my career, I started coding in 97. I was a listener of your podcast when you first started. I remember, and I personally learned a lot from you, and of course heard you speak at conferences. And so if anybody out there has not heard Scott Hanselman speak at a conference or hasn't kind of followed him and had the pleasure of learning from the content, I encourage you just to do that, to check him out, because he's a great teacher. And he did not pay me to say that. I wanted to ask you kind of about recent topics. .NET Conf, you were on with a few sessions, and one of them was with John Maeda, and you were talking about AI, and you've done quite a few talks on AI, and you're really good at kind of cutting through the fog and getting to the essence of what it is in this latest generation of what we call AI, that fuzzy term, and to how we can actually use it and how we can actually make the rubber meet the road. And for a year now, we've been doing cool things, Chat GPT and now Bard and Bing Chat and all this stuff. But now we're thinking, okay, I'm a developer. What can I actually do with it? And so at a high level, what should we be thinking for this year in 2024? What should developers be thinking when they try to answer the question, how can I actually put this to work in my applications?
I would probably tell people to back up and take a breath and get a good understanding of the base of the pyramid. While it is fun to say Chat GPT, and AI certainly exploded in the last year because it's fun to say Chat GPT and because the chat bot got people excited, these concepts of very large language models are not entirely new, and a lot of work has been done in the machine learning space. It's more fun to say AI and ChatGPT, but let's not discount, the 50 years of work that we're standing on top of. That said, I would encourage folks to start familiarizing themselves with how both large language models and very large language models like ChatGPT 3.5, 3.5 Turbo, 4, and things like Llama 2 work. And then think about where they're doing their work, what you expect from them, and then how you would incorporate them into your own applications. It might be initially attractive to the point of being overly attractive to just take some existing app and then just start throwing text at OpenAI endpoints, whether they be Azure OpenAI endpoints or just going and signing up for something at OpenAI. But is that the right thing for your company? Is that the right thing for your data? There's a lot of work to be done to think about this black box that we throw strings at and we get other strings back. And while it might be fun to say, oh, we have a lot of data, we have a lot of invoices, let's see what ChatGPT can do about it. That is the wrong way to think about it. We need to think about business value. We need to think about responsibility. We need to think about governance. Where is the data living? Is the data being protected as it moves around? Is it running in my data center? Is it running near my application? All those things to consider. So we start at the basics. How does this thing work? And is it really intelligent? Because some people would argue that it's not as intelligent as you think.
It's artificial, huh?
No, but it's certainly artificial. It is an oversimplification, as all good metaphors are. But one of the things that I talk about actually recently in my talk at GitHub Universe was it's kind of, from a generative perspective, it is saying the statistically most likely thing that would come next. So if you say, it's a beautiful day, let's go to the, just like Family Feud, what's the right answer? It's a beautiful day, Jeffrey, let's go to the
beach.
Right. So beach is the number one thing.
Yeah.
And if you go to Bing or ChatGPT or any large language model, 70, 80% of the time it'll say beach. But the question is, if I ask you that, what's the context? I've known you for 20 years and I might know that you like going to the museum. And that's context that I have because I know you and you would say museum, but ChatGPT or the very large language model is missing that context. If my wife asked me that, I might want to go to the bagel shop or the movies or the arcade. What is the right answer to it's a beautiful day, let's go to the? And the point is, there is not a right answer. There's only the statistically most likely right answer. And that's why the guy on Family Feud goes, show me beach. And then we see that it's the number one or the number two option. And then when someone throws out something like museum, we all laugh because it's the sixth or seventh most likely option. Who would ever say go to the museum? Who would ever say go to the park? Right? So ChatGPT is building all of that up based on context. And you can test this yourself by going into one of the prompts and giving a little context, like it's raining. I'm in Portland. I'm in London. I'm in Washington, and then see what it says. And sometimes it'll say beach, and sometimes it'll say, oh, well, it's rainy, you should go to the museum. Without understanding context, we can't make good prompts, and we can't give the large language model enough information about our history, whether it be our personal history or the history of the customer's data, for it to make something that is coherent. And as such, then you're effectively just rolling the dice, and you're asking statistics to make the decision. And for most businesses, that's not the right thing to do.
Now, Scott, you talked about the foundational pyramid to back up and understand what's going on under the covers. And so what are the levels of the pyramid that every developer should understand?
So this is the thing, like, where do you start? Like, how far down do we go? Do we learn the statistics of it? Do we learn the math of it? Do you need a PhD? Do you need to know the math? That's up to you. I like to say, pick the level that you understand and go one level below. Go level below your comfort zone. The analogy that people know that I like to use is the one about driving stick shift. If you know how to drive an automatic, learn to drive a stick. If you know how to drive a stick, change your own oil, change your tires, right? If you know, like, how far down do you have to go? I'm not asking you to like synthesize rubber or smelt your own iron just to make a car, but I am asking you to pick, some layer. So if you understand that a co-pilot's a thing, well, let's learn about AI orchestration. And if you understand AI orchestration, let's talk about foundational models. So understanding parameter size and how a foundational model works, and then how AI infrastructure happens, what is required to run a model, Running small models on your local machine is a good way to start learning a little bit. There are tiny models like Ada that you can run in a browser or on a Raspberry Pi, and then understanding the limitations of those and what's appropriate as you move from Ada to Babbage to Curie and up to DaVinci and larger models.
Okay. And so it's really just predicting the future because we're so early. What level would you predict that the average developer probably needs to actually learn? And what level would you say the average developer will just kind of rely on, quote, the cloud or rely on other providers?
Well, so when you rely on those things, you are trusting, you're putting all of your trust in something. And you trust Azure or AWS to run your website, but when the website goes down, whose fault is it? And this is a really interesting kind of philosophical question, because some people will say, well, it's Azure's fault, right? 100%. Well, it's actually not. You are responsible for your uptime, right? And you should be prepared. And if your site goes down, that means you didn't have two of them. And if they both went down, that means you're running them in the same region. And if they both, like we can yes and all our way to how hard do you want to work to get all 5 nines, right? 5 nines is like 16 minutes of downtime a year. Yeah. And as with all things, you're asymptotically approaching 1, but never approaching, never actually getting there. 2 or 3 nines uptime's easy. That 3rd or 4th 9, now we're making a big deal. 5 nines, well, yeah, now you got infrastructure. Yeah. You got to think about DNS. If you simply trust that, I have a virtual machine and it's fine, right? So the same thing applies to AI. If you just start letting humans type to ChatGPT, you will see it say ungrounded things, formerly known as hallucinations. You'll see it say perhaps problematic things. You may have any number of European governments on you because you're sending private data across. You will quickly outgrow the simplicity of sending a string of prose to a model and expecting something cohesive back. So you're going to want to start looking at projects like Semantic Kernel, or another one of my favorites is Type Chat, which is effectively TypeScript for AI models that basically strongly types what you're allowed to talk to your model about. So for example, if I have an existing application that makes coffee ordering, so I've got like an app and I want people to talk to it in plain language and it's for ordering coffee. We could potentially break into it and suddenly it's giving me taco recipes and it's giving me, mental health and therapy. It's meant to order coffee. So then how do you solve that problem? How do you keep it grounded? Grounding is the inverse of what used to be called hallucinations. You don't want to use the term hallucination when you're referring to an AI because you're basically anthropomorphizing the AI. You're treating it as if it is a mind. Yeah. And it's not a mind. It doesn't have mental health. And it will float away and start rambling about other things. So instead of thinking about hallucinations, we invert that problem and we think about grounding it. We're going to ground this in the problem of ordering coffee. So there's multiple ways to do that. You can do it with a complicated prologue or preamble, where you basically tell the AI all the things it's not allowed to do, and you end up playing whack-a-mole. If you remember playing whack-a-mole at the circus, right? And you're just going, psh, psh, and the mole, they're popping up, and you're smacking them, and you're always going to be playing whack-a-mole. Something like Type Chat allows you to say, here are the only responses that I am interested. Here is the menu of items, and here are the things I expect to hear from the customer. And just like a phone tree, press 1 for this, press 2 for that. And, you're always on the phone with Alaska Airlines going, talk to a human. And sometimes they understand,
real person.
They don't. Right. So locking those things down, strongly typing them is a really great way to not only ground your AI in reality, but do it more cheaply. It costs money. It burns carbon to talk to ChatGPT 4. You probably don't need ChatGPT 4 to order coffee. If I do 3.5 Turbo, it could be literally 16 or 20 times cheaper and less energy. All right, so we're talking about like an order of magnitude and change cheaper to get the same effect. Or even, what if I ran Ada or Babbage, one of the smaller models, because literally I don't need it to write a haiku. I don't need it to go and do the menu in the form of Shakespeare. I just need it to take the coffee order. Could we do this for 100 times cheaper with a local model that runs on the local hardware that I already have. Or in the future, we're going to see, in my opinion, local models on Windows, local models on iPhones, where we don't have to send the data anywhere. And just like people were very concerned about things like Alexa, sending the word Alexa all the way to the cloud and back, we, of course, learned that that work is happening on device. So thinking about what an on-device or what's called an edge-deployed AI model looks like is also a really important thing for developers to know. So that whole long speech there I gave, and didn't mean to, is a response to what should people know? They should at least know to ask those questions. The answer is they should not just start throwing strings at the OpenAI.
Mm-hmm.
Does that probably makes more questions, but I hope that clears up some things.
It does for me, certainly. You mentioned all these different types of models and GPT 3.5 Turbo 4. Are those different databases primarily, or are those different computing algorithms?
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Okay, so a foundational model is a machine learning model that's been pre-trained on a data set. And there are all kind of like AI neural networks, and they're trained on these massive data sets where the data set might be, the entire internet, all the blogs. It could be all the PDFs, whatever. It's text, it's data, it's speech, it's structured data, it's unstructured data. And then they train that on all of these things, and the training then kind of compiles, for lack of a better word, into a foundational model. It's usually done in slices. So all these millions of GPUs are running all this data, and they're each working on their own little piece. And that foundational model is trained on these mountains of raw data, using a thing called unsupervised learning. And then they adapt it such that it is a generalized model. And it really is kind of impossible to comprehend how big these kind of models are. Early models, we're talking about like petaflops of data on these things.
Can't even imagine
ChatGPT was trained, I think, on 10,000 NVIDIA GPUs, as I recall. There were early models in the early 90s, but they really, the idea of a generalized transformer, I think, was around 2017. I have to go and check my dates. And they all have different code names like Bert and Albert and Big Bird and all that kind of stuff. And they end up being a certain number of parameters. And there's about 50 major transformer models out there. And I think right now we only think about 3 or 4, but there's really many, many, many. And the problem is that they get bigger and bigger and bigger, and they're getting order of magnitude bigger. So for example, Big Science had one that was like 11 billion parameters in October of 2021. And then like 7 months later, it was 176 billion, right? So we're seeing, Meta comes out with one that's 66 billion, and the next thing you know, it's 175. So we're going to get into the trillions. This is where people are wondering, we don't know what it's going to happen. Is it going to be a brain? Is it going to just be big and dumb? Those things are unclear. But for example, there's a 530 billion parameter Megatron natural language model that NVIDIA talked about last year. That number is so big, you can't think about it. Like that's 530 million, like that's the size.
Hold on. Did you say that they called it Megatron?
Yeah, Megatron Turing.
They intentionally called it the leader of the Decepticons, the evil one.
I don't know why people name these
Optimus
things.
Prime might have been a little bit more positive.
Ultimately, these things get dumb names because there's some nerd,
That's right.
he or she thought that was a good idea, right? So these foundational models can then answer natural language questions and even write like short articles and stuff. But do they really understand them is the question. And they really don't. It's that they are connecting vectors of like almost the way we connect our own neurons. When you start talking to me about Star Trek, the part of the brain that has all the Star Trek knowledge starts to draw lines and, figure out the A to B to C to whatever. The problem is that we don't fully understand how it gets from A to C and jumps over B sometimes. And that's the moment when the AI seems magical, when the generative AI seems magical. And it's that challenge about like, well, I love that you did that, but I don't understand how you did that.
Yeah. Yeah.
But when you said, are they databases? They are generative, pre-trained transformer models. They are static. And they are static to the time that they were trained. So GPT-2 came out in October of 2019, and it was trained on 1.5 billion parameters. Now, ChatGPT-3 has 175 billion, right? So 4 years later, 100x bigger.
Yeah.
I don't know how large it is, but let's say it's many petabytes. It's not the kind of thing you're going to keep on a thumb drive.
Right.
But some of these can be kept on a Raspberry Pi or on a computer, but the amount of stuff that they can do is a lot less. So you might be able to tell one of these smaller models to summarize this text, like, hey, read this PDF and give me a TLDR, too long didn't read paragraph of the thing. But that one may not be able to go and translate Star Wars into Shakespeare.
Right. Well,
which would be something that one of the larger models might be able to do.
In your conversation with John Maeda, one of the things you talked about is semantic kernel and agents and making programs that could sit on top of large language models, but then actually do something or actually, integrate with some other system and call APIs and become active. Is that something for the future, or is that ready now? How should developers be thinking about that?
Okay, so you can oversimplify, and like I sent a string and I got back a string. But what you really want is you want to integrate these large language models into your conventional programming language. You've got C#, you got Python, you got Java. And for example, if I go and say, I used this example on my TikTok recently, and people should take a look at that, where I asked a large language model to give me a list of the colleges that my son had applied to, figure out the percentage of the admissions rate, the number of kids that go to that school, and how much it would cost. That's a pretty sophisticated task.
Yeah.
If I asked ChatGPT to do that, it has that data perhaps if it was trained on it, but it's frozen in time, like November of 2022. Yeah. So I don't know if that's up to date. So then the plugin, in air quotes, would be like Bing. So then we go out and we Google with Bing, and it goes and it's talking, and it adds that little bit of data. Maybe it gets a couple of paragraphs, maybe it gets a dozen paragraphs, and it's like a delta, and it puts it on top of the pyramid. So now we have a bit of an orchestration here, where I've asked an assistant for a task, it's run off and Googled and got all that data, and then there's the assemble a table, which is a task of its own. And I said, assemble the table in Markdown. And in the future, I might say, and make me a chart, and generate me an Excel sheet. Yeah. And then I might say, and text my wife the results. That's not large language model work. That's plugin work. So the plugin could then talk to, the Microsoft Graph API and find my wife's phone number and then send that off with Twilio or whatever. So Semantic Kernel allows you to orchestrate plugins, have a bunch of plugins that are all different agents, and then generate a plan to achieve a particular goal. So, for example, you could, call a travel agent, and that travel agent might have an assistant that does the billing and another assistant that goes and calls the airline. Each agent has their own roles. Semantic Kernel defines agents as being specific. You might have a researcher role and a compiler role and a fact checker, and they're all different. And that allows you to have single responsibility principle within your plugins. It also allows you to manage what data is seen by which one, because it might be okay for one person at the travel agency to see my credit card, but I don't want the fact checker to see that because it's just not necessary.
Yeah,
right. So Semantic Kernel is special by its ability to orchestrate plugins with the AI kind of at the center of it.
That is exciting for me because it actually makes a lot of this actionable for developers. And with the agent language, it gives a design pattern that people can kind of get their head around and align and start building programs. Is the Azure OpenAI service, is that kind of the one that this is intended to layer on top of, or are there several choices?
So the Azure OpenAI service is the Azure service that provides access to the OpenAI very large language models through our infrastructure. So if you are an Azure person and you're running in West US 2 and you want your West US 2 data to stay on West US 2, you could have a website call a GPU in the same location and you have control over that. If you were going to call OpenAI directly, you're going to go over the open internet. So that may or may not support the governance model and the data provenance model that your company has decided is appropriate. Right. And if you're, in the German data center, you might only want that German data for Germans staying in their own space. So it is an instance of that. All right. You could license that yourself. You could have like Palermo Cloud. You'd call OpenAI, you'd license their model, you'd get all the equipment, and then you would sell access to that. Additionally, there are filters. There's also like semantic and abuse filters to prevent naughty stuff in and naughty stuff out that Azure provides that are part of the pipeline of entry and exit to and from that OpenAI model that may or may not exist if you were talking to OpenAI directly. So it's like you want to watch, sci-fi. You can get sci-fi from Cox Cable. You can get it from Comcast Cable. Each one of those is a different provider, and they may or may not, change that, whether it be change the color grading or the view or whatever. They can add their own filter and add their own value add or not.
Yeah. Man, there's so many ideas. And you mentioned the smaller models that could even run on a really mini computer or Raspberry Pi or something local. And it just seems like in the next 10 years or maybe less, this is just going to go everywhere. I just imagine talking to my Ecobee smart thermostat, which is already Alexa enabled, so it understands some language integration, but just asking it, hey, what was the average temperature over the last week? And just asking it for trends, and it's interpreting things. And then I say, hey, it's a little bit cold. Can you raise my average temperature by 1.5 degrees, please? And it says, yes, sir.
Right.
And it does whatever
but
setting
see,
it
that
needs
brings
to
up
do.
really interesting issues around data provenance, though. And if you are familiar with things like Home Assistant is an IoT hub that runs inside your home. So it would give you everything that you just described with your Ecobee, but it would not require the temperature of your house or you speaking to leave the building. And that's really interesting. And that's why, there's articles you can find on how to run like Llama or Llama 2, which are large language models, on a Raspberry Pi. So you could potentially have an Alexa style communication experience running in your house, and none of it would ever leave the house. You could even have no internet, and it would still work.
Nice. I remember building some Alexa-enabled programs, and it was literally a sentence with some keywords, plug in, because it only knew you had to say it exactly right. Whereas now, even with, we can't call it a large language model. We have to call it a relatively small language model. All it needs to know is the English language, and you can be conversant and activate an agent. Am I thinking about that right?
Yep. But then also you're getting away with a lot because Alexa is having all that data go up into the cloud and do that work. I'm actually surprised that they haven't turned on smarter. Like Alexa's still kind of not clever. You know what I mean? I kind of expect more from Alexa.
Right.
Given that it's just a speaker, I'm surprised that they haven't turned it on and like turned it up.
Right.
made it smarter instantly, because it shouldn't require an upgrade.
That's true. Well, there's so much to explore here, but before we go, here in 2024, for a developer that just says, I really want to dive into AI, should they be going directly at Semantic Kernel? Should they be integrating? What would be your final thoughts for developers who haven't even touched any of this stuff yet and they want to dig in?
I would say like some of the hello worlds from Semantic Kernel, if you're like a Python or .NET developer, would be a good place to start. I would encourage you to go through some of the Microsoft Learn. We just released a complete like how to understand generative AI course. Just, take the time. It's like a 1 week, pace yourself kind of a course. And then I would also encourage folks, here's a little bit of an advertisement, to listen to some of my podcasts, because I've done talks with AI ethicists and people that can talk to you about, balancing all of these things. Just looking at my my recent shows. We did one on balancing science, policy, education, and AI. I did one with an actor from the Hollywood strike who was concerned about AI taking her job. I did a show with the CEO of an African AI company that talked about wanting to keep African data on the African continent, as well as, of course, that show that with John Maeda talking about where AI is coming with this. Like, don't forget that AI can do crazy stuff. It is a unhinged self-driving car. And if you run somebody over, it's still your fault. You had your hands on the wheel.
That's right. It's a machine and the operator is culpable.
Very well said, sir.
Well, Scott, thanks for coming on the show and sharing with us your thoughts and experience with Semantic Kernel and artificial intelligence. Thanks so much.
Absolutely my pleasure. Thank you for having me.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.